So now we need to talk about where that sediment's actually going to come to rest. So where it's going to undergo that lithification process. And that's what we call the depositional environment. There are literally hundreds of different types of depositional environments where water or wind is going to slow down, or ice is going to slow down to deposit material. Usually we're going to see this material dropping out to get deposited where we have a change in velocity, right? That's usually going to be what it is. But we're going to take a look. We're just going to take a very brief survey of these, and we're going to look from terrestrial ones going from the land out to the ocean. If you want a deeper look, this is where you take a class like stratigraphy and sedimentology, which is another class that I teach. And this is where we kind of look at these depositional environments a little bit more closely to see the kind of structures that we can get deposited in there. But let's start out with our terrestrial environments. So we're all above sea level. We're up on the land. One type of environment is a glacial environment. This is where we get ice. Ice acts like sandpaper as it moves over the rock, so it's highly abrasive, and it's going to pick up that material and carry it. And it can actually carry it a really far way. It can pick up both little and big pieces. It's not very discriminate. And what will happen is as that, it's going to entrain all that material, as you can see in this picture here. And what happened is as this glacier melts and retreats, all that material is just going to get dumped. So you get a very immature pile of sediment where it's just a nice big mixture of unsorted or poorly sorted gravel with all of your other grain sizes mixed in. Mountain stream environments, right? So as you work down from those glaciers, that water is going to come down the mountain. This can carry lots of material during flood times, or little material maybe during the winter. During low flow, you're going to get small particles. During higher flow, you're going to get bigger particles. What we tend to see is lots of conglomerates tend to form here because as it's moving down the mountain, those big high angles on those rocks are all going to get worn off. At the base of our mountains, we're going to get what's called an alluvial fan. So this is due to a gradient change, a velocity change again. So here we have our mountain. There's our base. Again, this is highly exaggerated. So your water is working its way down the mountain really, really fast, and it hits the base of the mountain, and it's going to start to slow down. Because that water slows down, it can't hold as much sediment, and that sediment's just going to get deposited. So you can see it gets deposited here in this nice, big, beautiful fan shape. We call that an alluvial fan. We tend to find some pretty immature conglomerates. Arkose, remember that's the sand with at least 25% feldspar in there. So, you know, kind of that submaturity type rock. Then we can find sand dune environments, which we just looked at dunes a few minutes ago. Sand dunes, this is all wind-blown, right? So no water here. And most of this material tends to be pretty well sorted because the wind is, again, just like the velocity of the water, selecting for a size of sediment. You can get huge crossbeds. This picture over here on the right is a pretty fantastic picture. This is Zion National Park in Utah. These are huge, huge dunes from the Jurassic Age. And if you take a look, first of all, you can see there's people down here. These are people way up at the top. So these are huge dunes, and these are big crossbeds right going down it. So it's really quite spectacular if you ever find yourself out in that part of the country. Plain old river environments are actually very complex environments, and we're going to spend a whole chapter talking about rivers. But as the rivers move and migrate over time, they can have varying amounts of speed, varying amounts of sediment that can get deposited there. Usually we tend to find lots of sand and gravel in the channel. On the floodplains, you tend to get smaller sized particles. But rivers are pretty complex beasts. Lake deposits. Lakes are kind of like oceans in the sense that they don't move very fast, and they tend to be fairly deep, so you get lots of that small particle, silt to clay sized particle. Sometimes we can find that shale that'll get deposited here. So here, this is a nice lake deposit. You can see all that beautiful fine lamination there, all those nice layers. Now, as As we move from the continent out to the ocean, we can get these transitional environments. The first one is a delta. So a delta is where the sediment drops, where a river either enters into a lake, or in our case, right, with the Mississippi, where the river can enter out into the ocean. So let's go ahead and add that from the author, right, out into the ocean. What we tend to see, and it really works the same way as the alluvial fan. Again, think about the Mississippi River. It's moving really fast. It's carrying a lot of sediment. It hits the Gulf of Mexico. Gulf of Mexico isn't moving very fast, so the velocity of the river drastically slows down, which means it can't hold as much material, and all that material drops and gets deposited. What we tend to see are there's three parts of your deltas. You can get the bottom set beds, which are way down your bottom, the foreset beds, which are in the middle, and then the top set beds, which, if you notice, that they are all cross-bedded. Right, so again, telling us about that direction of water movement. So out in our marine environments, right, again, like I said, we get our delta. But as we work out from the delta, as we move from the delta all the way out to the deep ocean, we can see some pretty typical deposits there as well. As we move out, we can get our beach. And of course, beach sand moves across the coastline as the waves bring it in and bring it out. Again, down here you can see these nice symmetrical ripple marks from that water moving in and out. Because the water is constantly working it over, we tend to see that beach sands are well-rounded and well-sorted. And most of the time that means they're going to be that quartz sandstone. We don't tend to find that at our coasts very often on those nice, well-established beaches, because that water is really going to work out all of those other minerals except for quartz. We can, as we move out from the beach, we're going to move out into the shallow marine. So the water is going to be a little bit quieter. So we're going to find fine sands and silts out there. So we can get our siltstones and our mudstones. This is where we're going to get lots of life out here, lots of animals. You can see it makes these nice layers that are down here. As we move, I don't know what happened to number 3, but as we move a little bit further out in that shallow marine, if we are in the right location, right near the equator, we're going to get that carbonate environment where we're going to get our limestones. So remember, limestones are the coral reef. The water's got to be warm, tropical, clear water. And sometimes what's really neat is we can get these nice. So here we've got a volcanic island, and we've got this reef that's ringing around it. And because that reef is around there, this water on the inside here is nice and protected, and we call that a lagoon. So the water is really not affected very strongly by the wave action, right? It's being protected by that reef. So that's really nice. Then as we move out to the deepest, we can get deep marine deposits. So we are way out in the deep ocean. The way out deep ocean doesn't move very fast at all. So this is where we're going to get our finest particles. And a lot of times out in the deep ocean, we're going to accumulate a lot of organics. And way out here, we might find chalk. This is the White Cliffs of Dover, but this is a big chalk deposit. And chalk is made from these tiny organisms called coccolithophores, or coccoliths. Coccoliths. They're these little tiny organisms. You can see you can fit one of them there in the head of a needle. When they die in mass death layers, their little bodies float down to the bottom of the ocean floor, and they can get compressed, and they form chalk. So that's our depositional environments. Again, there's many, many more. There's literally hundreds more, but these are kind of the big, most common ones that we see.